Hello everyone. So today let's solve the problem number 778. Swim on rising water. Right. So let's see what the question states here. We are given n into n grid. So here, see in the first example they have been given us this one 2 into 2 grid. Right. So we have given n into n grid of elevations. Right. At time t, all the cells with elevation less than t are under water. Right. So what they have said here, at time t, at a time t means particular time T, all the cells means individual cells here, four cells, right? All the cells here, this one with elevation less than or equal to T or underwater. We can move four directionally between adjacent underwater cells, right? So we can move four directionally between adjacent underwater cells, four directions in the sense either we can move up or down or left or right, right? Up, we can just move up, down, left, or right by one step. Just remember this. We can move four directionally between adjacent underwater cells. We must find the minimum time t, right? So what we need to find here, we have to find the minimum time t when it's possible to swim from 0, 0, 0, 0 means starting from the first top left cell, right? So starting from the top left cell, when it's possible to swim from 0, 0 to n minus 1, n minus 1, the last cell. N minus 1, n minus 1 is nothing but the last cell here, last cell, this one. So we must find the minimum time t when it's possible to swim from 0, 0 to n minus 1, n minus 1, top left cell to the bottom right cell in simple terms, right? So essentially, we need the smallest time t so that valid path exists from the start to end, right? So this one, so we can solve this problem with this one, I think, Bellman-Ford or the Dijkstra. Or we can just go with a Floyd-Warshall or the Dijkstra. It's better we are having all this one. What do we call? Uh, this one, positive values itself. So let's do one thing. Let's go with the this one, Dijkstra's itself. But yeah, let's go with the Dijkstra's itself. Basically, Dijkstra's uses priority queue, right? So it's faster compared to this one, Floyd-Warshall, right? So let's do one thing. Let's go with the Dijkstra's itself, right? So first thing, so let's go with a graph plus minimum heap or priority queue. Nothing but so we'll be making use of the Dijkstra algorithm here. If you don't know the Dijkstra's algorithm, you can just go to the graph-based playlist and you can just check there. So there are all the most of the algorithms that are related to the shortest path and other stuff, right? So mostly graph in the so that's related to the graph. The name itself indicates, right, that it belongs to the graph algorithms, graph based algorithms. So you can just go through the playlist. So there are around 19 to 20 algorithms, actually, to be exact 19 I believe. So you can just for now we are implementing the Dijkstra. You can just go through the this one Dijkstra's algorithm. Dijkstra's algorithm uses this one, minimum priority queue. I mean priority queue, actually, right? So it uses priority queue. So it's better to know the this one algorithm. You'll understand the implementation quickly here. So you will be able to implement certain things very quickly. I wouldn't lie. If you don't know the algorithm itself, it will be hard to understand, right? So first, let's do one thing. Yeah. First, let's do one thing. Let's directly discuss this one approach by considering the example one. So later, you can just try to do the same by considering the example two. I insist you to try with the by considering the example two, actually. First, let's do one thing. Let's move on with the first step here. Let's move on with the first step here, right? So let's consider the same example one within the question that they have given. So we will start from 0, 0. So they have asked us to start from 0, 0 and end. So this one, right? Until end. So the first one, we will start from the cell 0, 0 actually, which has the elevation 0. So elevation 0 in the sense, so this one value, this is nothing but the elevation, right? So we'll start from 0, 0, which has the elevation, I'll consider E here 0. So current water level, I'll just write WL, nothing but the water level, current water level is 0 itself. Yeah. So this is the first step. Let's move on with the second step here. Let's go step by step, uh, slowly, so that we understand this one clearly. So the next reachable cells depend on the highest elevation we must cross, right? So we always choose the minimum elevation neighbor using a minimum heap or the minimum priority queue, right? So we always choose the minimum elevation neighbor using priority queue, right? A minimum priority queue, similar to the Dijistra's shortest path, right? So we will be simulating the Dijistra's shortest path using the minimum priority queue. See, from 0, 0, we can only go to 1, 0. So the minimum one here is from 0 is 1. So either we can move this one, we can either move up, down, left, or right. Four directionally they have mentioned in the question, right? Which is the lower value actually, lowest value actually here among 2 and 1. The lowest value we have is 1, the elevation 1, right? So what we will do from 0, 0, we can only go to 1, 0 and 0, 1. So we will take 1, 0 first since smaller elevation. So we will consider the one with a smaller elevation. We can just move to 2, or we can just move to 0, 1, or we can just move to 1, 0, right? So this is 1, 0 and this is 1, 1. So let's move to the cell 1, 1 because it has the smaller elevation, nothing but the value. See here, 2 and 1, which is having the smaller this one value, nothing but 1, right? So we will be moving to 1, 0. So here we will be moving from 1, 0, 0 to the 1, 0, right? 1, 0. Yep. So next what we will do, the next step. So we so max elevation so far is max of 0, 1 actually. Max elevation so far is this one. We have the value 0 and we have the value 1. So we will be going with the max itself. Max of 0, 1 is nothing but 1. So still uh, we can't reach 1, 1. Nothing but still we can't reach this one 1, 1. Still we cannot reach actually 1, 1 means the last this one cell actually, right? So this one 1, 1. Still we can't reach actually the last cell, or in this case for this example 1, 1, right? So this is fine. Let's move on with the next step. Then what we have to do, so next from 1, 0, we have to move, we can move only one step. So up we have already started from here itself. We cannot move this one, move to this one above cell from 1. So diagonally we cannot move to 2. So we have only one, but down we don't have any cell as it is 2 into 2 grid. We can only move to the right path from 1, 1 to 1, sorry, 1, 0 to 1, 1, right? So what we will do next from 1, 0, we will move to 1, 1. 1, 0, we will move to 1, 1, nothing but with a value or the elevation 3, with the elevation 3, right? So now we will consider max elevation from this one 0, 1. We already got the max 1 here. So we will be going with this time, we will be going with max of 1, the previous 1, and now we have successfully moved to the last cell. So the elevation here is 3. So max of 1, 3 is nothing but 3 here. Max of 1, 3 is 3, right? So here we have successfully reached the destination, and this is the last cell. They have, that itself they have asked in the question, right? So now the max elevation is max of 1, 3, which is 3. We have successfully reached the destination. So minimum time required is 3. So this one we will return this one as output. So minimum time that is required is 3. Basically, we have got the output 3, which is equivalent to the output that they have mentioned for the example 1 within the question, right? So our approach works absolutely correct. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. Yeah, let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would lead to big O of n square log n. The time complexity would lead to big O of n square log n. Each of the n square cells is pushed and pop from the priority queue exactly once, right? So the time complexity would lead to big O of n square log n. So what will be the space complexity then? This one space complexity would lead to big of n square, because we will be marking the matrix visited, marking the matrix cell visited once it is visited, right? So we'll be considering this one visited matrix and the priority queue storage, right? So overall space complexity, it would lead to big of n square. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n square log n and big of n square respectively. Now, as we are completely familiar with the approach as well as the complexities part, we are good to write the code. Let's start writing the code, right? So the first part here would be, let's do one thing. We'll be making use of the length of the grid everywhere. So let me assign this one to the variable n. So I'll just go with the grid dot length, right? So we are just getting the grid size actually here. So this is fine. Let's go with a 4-directional movement here. So I'll just go with here. Let me go with the keyword directions, DIRS. So this one will be 1 comma 0, 1 comma again 0. So this one has to be minus 1. 1 minus 1, 1 minus 1, 0, 0, 0, 0, 1 and minus 1 for the column, right? So neighboring row, neighboring column, we have to mix up as it is 2 degrees actually. So we have to go with a 4-directional movement, right? So this one is, so let me leave the comma or else we'll be getting the error. Yep, so this is fine. The third one is 0, comma 1 and the fourth one is 0, comma minus 1. Yep, so this is fine, I believe. Yeah, now we have to track the visited cells as well. Just now we discussed on the space complexity, the same thing. Yeah, so I'll just go with visited keyword itself, right? So this will be new boolean of, we are going with the n into n grade, right? So which is of size n and n respectively. Next, let's do one thing. This is very simple. Listen to me carefully. So here, minimum heap stores elevation, row, column, right? So these three things. Minimum heap stores elevation, row, as well as the column, right? And to get the smallest element, this one, smallest elevation first actually. So we have to get the smallest elevation first. We'll start from 0, 0. So we can move 4 direction, right? In this case, in the first example, we can either move right or we can move down. So from this, we have to get the smallest value itself, right? So we have to get the smallest value every time. For that purpose, we'll be making use of the minimum priority queue. We know this one, right? So this is simple. Now, minimum heap stores elevation, row, column, smallest elevation first. So I'll just go with the priority queue here. Priority queue. So let me go with int. Yep. So this is fine. PQ equals new. Let me copy this one entirely. Let me paste it over here. Yep. So this is fine. So I'll just go with A comma B. Let me go with A of 0 minus B of 0. Yep. So this is fine. The next step is we have to start from the top left cell, right? So I'll just go with priority queue variable PQ dot offer of, as usual, new int. So this one I'll just go with here. Let me go with grid of 0, 0. Along with it, we have to go with elevation. What are the things that we have to go with actually? Elevation, row, as well as the column, right? So elevation, this is fine. Row, column 0, comma 0. Yeah, 0, comma 0. We'll be starting with the 0, comma 0 itself. Yep, initially. So this is fine. Let me come out of this. Finally, we are just starting from the top left cell here, nothing but the 0, 0. That's what we have mentioned. This is nothing but the elevation. Yeah, elevation. Grid 0, 0, sorry. This one row as well as the column elevation, the value that they have mentioned accordingly with the input. So this one I'll just go with the visited of 0, 0. Initially, let me set this one to the right? So the first cell, 0, 0, we have set this one to the true as we have visited. So next, we have to track the max elevation that we went with so far, right? So let me initialize the variable time to 0. Let's consider, or let's go with the variable time for that. Yep. So next, let's go with this one standardized priority queue loop. So I'll just go with while pq dot is empty. So this is fine. Is empty. So within the while loop, we have to take the smallest elevation cell, right? So I'll just go with here current equals pq dot poll. Yep, pq dot poll. So this is fine. The next one is int h equals current of 0. This is fine. R equals current of 1. So this is also fine. C equals, I'll just go with, let me assign this one to the current of. So this is simple, man. Now the water level must be at least this one, this elevation, right? So we have to go with the max. We have to go with the maximum of whatever the this one elevation level that we get actually from the directions, right? So this we had discussed in the approach already. So I'll just go with math dot max of time comma h. Simple. Yeah, let's move on with the further steps. If we have reached the bottom right cell, the last one, then we have to return the current water level, nothing but the time. For that, let's write the simple if condition here. If r equals n minus 1 and c equals, so this one, n minus 1. So let me return time. Let me return time. Yep, so this is fine. Now let's do one thing. We have to explore all the four directions, right? So let me go with a simple for loop here. So this one has to be d of direction. So within the for loop, let me go with a neighboring row, nothing but the nr. Let's assign this one to row r plus d of 0. So this is clear, I believe. So let me consider neighboring column nc. Let me set this one to the column plus d of 1, right? So this is simple. So let's write the simple if condition. So this is for the bound check. Let's go with the bound check. nr neighboring row shouldn't be greater than it has to be greater than or equal to 0, right? And sorry, next let's go with n has to be less than n, and nc greater than or equal to 0, and this one actually nc less than nc less than and let me go with not of visited of neighboring row as well as the neighboring column. Yeah, neighboring row as well as the neighboring column. So I'll just go with visited of nr as well as the nc. Visited of nr as well as the nc. Let me set this one to the boolean value true. Right. So the final one is we have to add the next cell. We have to add the next cell to the heap. I'll just go with pq dot offer. So this one will be new int of do one thing. So within this, I'll just go with here grid of nr nc neighboring row as well as the neighboring column. Yep. So this is fine, I believe. Let me come out of this one entirely. We are left with only one thing. So actually, we don't have to return minus one. So basically, even if we return minus one, that's not wrong. Uh, this line will never be reached, even if we give return minus one, right? So grid is always fully connected. They have mentioned in the question. Even though, let me give here. Let me do one thing. What shall I do here? Yeah, even though let me give here return minus one. Anyways, so let me format the code and let me hit the run button. Yeah, sample test cases are getting passed. So if I remove this one, then also it has to work actually. Let me hit the run button. Compilation error. Missing. Oh, we have to return something. So just give me a second here. So yeah, this works actually. Let me give the return. This one. Sorry, we have to mention the return string, right? Yeah, all the test cases are getting passed. So whatever the code that we have written works absolutely correct for all the test cases, right? So I hope the solution part is completely clear along with the approach as well as the complexities part. So this is purely this one. We have went with the priority queue to solve this problem. We have simulated this one, Dijkstra's algorithm, this one to find the shortest path. That's similar, actually, not entirely. We went with the algorithm. Actually, we have simulated this one through the minimum heap, right? Minimum priority queue, basically. Yep. So this is fine. Yep. And again, if you want to learn any graph-based algorithms, if you don't know, if you just want to this one brush up, if you don't remember, uh, we don't mug up, right? So we just have to see this one every time. So you will be knowing the implementation, but after some time you might have forgotten. If you want to know the graph or graph-based algorithms, you can just go through the graph playlist actually and just have a look into the algorithm or have a look into the video and come actually, right? So this is fine. Yep. For now, this is it. Thanks for watching, guys.